Welcome to another presentation on the products for aviation weather hazards. And this video will cover convective segments. Now, convective segments came about in the late 1970s after an accident. Southern Airways DC-8 crashed in Alabama. It flew through a line of thunderstorms, and that information was not passed on quickly from the controllers to the pilots. So they deemed that it was necessary that convective weather, in other words thunderstorms, that weather information get passed on to pilots quickly. So they created a new product, and that was called convective segments. We use the abbreviation WST. And convective segments, of course, are for thunderstorms in the contiguous U.S. If you look at segments from around the world, they typically contain thunderstorm and convective weather. Here in the United States, since we thought it was so important that thunderstorms be noted and passed on, the information passed on quickly, we created our own called the convective segment. So there are criteria for the convective segment. And those criteria, they won't just issue a convective segment for just a small garden variety thunderstorm. It has to meet these criteria. And the criteria are that it needs to be one of these things, either a severe thunderstorm, and severe thunderstorm, as you know, has to have winds greater than 50 knots, hail bigger than 1 inch in diameter, or tornado. Any one of those things makes the thunderstorm severe. An embedded thunderstorm, or embedded thunderstorms, are ones which are hidden by haze or clouds or precipitation. So that's another criteria. The thunderstorms, if they're embedded, a convective segment will go out for them. Also, a line of thunderstorms is also a criteria. They'll issue convective segments for lines of thunderstorms. And they need to be at least 50 miles long and also affecting at least 40% of that line. And then the final criteria for convective segments is an area of active thunderstorms. So it could be just generally thunderstorms, but they have to cover an area more than 3,000 square miles, which is your 50 by 50 square box. It's a nautical mile square box, that is. And then their intensity, they have to be greater than 40 dBz, which air traffic control classifies as heavy. And then they need to cover at least 40% of that box. Convective segments come out 55 minutes after the hour, or if you like, 5 minutes before the hour. They cover 3 regions. There's the East, Central, and the West. They use the MKC identifier because that's where the Severe Storms Forecast Center is located back in the 1990s, and they haven't changed it. So there's your breakdown. Those are the lines of longitude that denote the East from the Central from the West, and they'll issue convective segments for each region. These are, of course, they come out every 55 minutes after the hour. And they start numbering them starting at 0 Zulu. So it's a very active day. You'll see sometimes convective segment numbers that approach 100. But they'll issue them for each region, and then they're valid for 2 hours, and they update those every hour. And as I said, they start numbering them at 0 Zulu, and if the weather phenomena continues, they will reissue with a new number. There's an outlook that's added to the convective segment, and it gives you a forecast of thunderstorms for 2 to 6 hours into the future. Typically, it's a larger area than just the convective segment area. And lately, meaning within the past 6 years, they've gone to kind of a standard outlook. They use the convective outlook from the Storm Prediction Center. If there's no thunderstorms, then the convective segments will say none. And of course, thunderstorms can pop up very quickly, and if they do, they will put out a special bulletin. They won't wait till 55 minutes after the hour. Here's an example of a convective segment. This one is the one that's out of your book, so if you want, you can read along. But of course it is MKC, which stands for Kansas City. C is the central region, so this is the Central Region Convective Segment. The WST is the abbreviation for Convective Segment. 22 is the date, and 1855 Zulu is the time. It's Convective Segment 20 Charlie. It's valid until the 2055 Zulu. So you can see it's a 2-hour forecast. It covers North Dakota and South Dakota. And then they give you the area from 90 west of Minot to Grand Forks to Aberdeen to 90 west of Minot. They say an intensifying area of severe thunderstorms is moving from 240 at 45 knots, and the tops are above 45,000 feet. And here are the hazards. Wind gusts to 60 knots reported, tornadoes, hail to 2 inch, and then winds gusts to 65 possible in the North Dakota portions. So that's the breakdown, line by line, of the convective segment. Here's another example. This is one that I pulled a couple of years ago. This one's covering Florida and Alabama, and it's still for the central region. It's 35 Charlie. And you can see that it was issued at 1455 and it lasts until 1655. They give you the region, all the points, 50 southeast to IGB to 30 southwest to LGC, so on and so forth. And then they say it's an area of severe embedded thunderstorms moving from 250 at 30 knots, tops to 42,000 feet. And they say tornadoes, hail to 1 inch in diameter, and wind gusts to 60 knots are possible. I know it's kind of hard to plot all that, so if you go out to the Aviation Weather Center, they plot it for you. They use high altitude VORs, of course, as their points. So that is one of the areas that you see there in red. Remember, convective segments are issued, or any segment is issued in red. Here's an outlook. This is the one for the one I just showed you, and it says that it's a 6-hour, actually a 4-hour forecast, valid from 1655 to 2055 on the 13th. They give you the points, the high altitude VOR points, and they say reference WW19, which means Weather Watch 19. In other words, that's either severe thunderstorm or tornado watch box. And they say the convective segment issuances are expected early in the period. Refer to the most recent ACUS-01 KWNS from the Storm Prediction Center for synopsis and meteorological details. So basically they just outline the area, and then they say go to the Storm Prediction Center, look at the convective outlook, and basically that's your outlook. So in years past, a long time ago, they actually used to give you an outlook. Now they tell you to go someplace else to look for an outlook. This is another example of a convective segment. This one's for the East region, and they say it's a segment 13 Echo, and it's a 2-hour forecast off the Florida coastal waters, and they give you the points of reference, and they say it's an area of thunderstorms moving from 250 at 20 knots, and the tops are up to 37,000 feet. Since this is over the waters, they reference the International Sigmet Alpha series for this. In other words, there's also some thunderstorms over the waters that are further out that are issued as international segments. So here's an outlook also for that same area too. But those are all the thunderstorms that are off the Florida coast. So you can see the outlook area is highlighted in yellow, and the one that we just read is the one that is off the east coast of Florida over the ocean. That's all I have for convective segments for you today.